designing? Look at the very top of the lab report. Are we inquiring and designing? Do we have a problem? Are we developing a hypothesis? Okay. Do we have procedures, steps that we're gonna follow through for the lab? Yes, 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 yes. So right now, what I need you to do is think about, when I'm explaining what we have on the lab tables, think about what are the variables, but don't write it down yet. What are the variables? What's the problem? What's gonna be the hypothesis? All of that is gonna be on page 1 of the lab report, okay? So, we got density cubes. Now this lab table has four density cubes, and they have letters. Crucial that you keep the labels on. Please, I don't have time to set this up again, so the labels need to stay on. Now, then over here we have 5 cubes, okay? And different, they're all different. And look at it right there in the lab report. There's 11 in total, and they're labeled. Those letters are the label for the substance material that makes up the cube. And here we only have 2 cubes because we're also going to be doing liquid volume. So I'm going to come back to that, okay? And I record the mass, and it's going to be the same. So, mass, the amount of matter, the amount of stuff in something is going to be this device. What about this, though? We're not using it today. What is this about?
Weight.
A digital scale, okay? Is this going to measure mass?
No.
What was the other word some of you said?
Weight.
Weight. You see, I take this to the moon, and I put the same cube, and it's going to give me 1/6 the weight. It's not going to give me the same value. It's going to give me a substantially different value, 1/6, because there is a lot less gravitational pull on the moon. Remember, from IBMYP philosophy, criterion B, I need you to determine what are the variables in this experiment. So what is the independent variable? What is the dependent variable? What are the variables? Then, how are we going to determine the density of the cubes? What are we going to do with these cubes to determine the density? And finally, I know there's not a lot of space here, but you can use the side margin. Can we change the density of the substances, of the cubes? If we were going to change the density, how? If it's possible. So I need to formulate these answers. Go ahead, get a pencil, pen, write it down right now before we get to the lab table. This is our inquiry, the design part of the inquiry. We're designing this experiment, and then we're going to do a hypothesis, but we're not ready for that yet. So let's answer items 1, 2, and 3. Like, write it down, Mark. Oh, you did. Beautiful. Thank you. You already have it done. Excellent. Yeah, I moved them, so get it, Emily, over there on the 10-5 desk chair. Yeah, now you can go and follow procedures. The passes are there. Without looking at the cubes, just based on your pre-existing knowledge of these materials, predict the density order 1 through 11. 1 would be the most dense, 11 the least dense, and they don't share the same density. They all have unique densities, because density is a physical property of matter that helps you identify the substance that you're dealing with. So put that in. Then as you work on that data table for the hypothesis, well, think about the rest of it. The rest of it is processing and evaluating, which is criterion C of IBMYP. Have a word that has a color written out, okay? Silver, A, gold, B, pink, C, green, D, black, E, and red, F. Showtime. As soon as you're sitting down, we get the timer going for the element. File them up on the lab table, please. Thank you. I'm waiting for everybody to be sitting so that we can get the timer going. Quick. If I see you hesitating, you get to sit out. If you don't know your color, let me know. You don't know where to go. I don't want to see people drinking popsicle sticks. They're the ones that have. You gotta pull out. You're here to eat. You're doing
So, I have to find out what's gonna do code.
It makes sense. Acrylic's gonna be. Okay. Wait, is it heavy?
Okay, so we start.
Alright, teamwork, I like it.
Question. For the order room, is it?
Oh yeah, it's 1 to 11. 11 being the heaviest, 1 being the least.
Okay then.
What is that? Popsicle stick, I mean. Thank you.
PVC. Okay, so what we have to do is we have to mash the grams. So just pour out the rest of the oil.
Should I pour it all? Hold on.
And then,
How much do you pour?
then you're gonna
20
You're
ml.
gonna start with this one. It did not work, right? It's not enough because this needs to come down. It needs to level right here. So you're probably gonna need to come around this way so you can see what's going on.
And why do we measure the cylinder empty to start?
So we could find, so we could subtract it from the like heavy amount of it, like whenever it's
So if you look at the,
That's good, that's perfect.
what's it say?
so it's either it clicks or it doesn't click. So you notice that this one,
Yeah.
it's not enough.
7.8, and then
Now,
that's 9.
we're gonna use it. 10, not enough. I have to click 20, too much. I go back to 10 and I click it. And now, I move this one until it levels, but you know, my finger is not too big, so then I like doing this. Like, the patient, you just slide it and it will level. Because it's gonna be between 10 and 20. We know that because of what happened. That makes me nervous. You have them on the floor.
I got it.
Great job, I like what I see.
Got it. That's it. No, yeah.
Is it really no? Not yet. No. Can you move it like the tiniest bit? Can you do one? Half a minute.
Let's move it down.
I know it is.
Alright, one more. Why are you moving it down?
Wait.
Oh wait.
A little more. More. Keep going. Wait. Right there. Wait.
Stop moving.
Very precise.
A little more. No more. Oh, you're moving it back.
It's 0.67.
2.3 centimeters.
I don't think the aluminum's gonna be the heaviest.
Wait.
You still working on the same thing?
Yeah, 2.4.
Times what?
Times length.
I did.
That's, yeah. Length.
Hey guys, how's it going?
2.4.
Hey guys, it's multiply here.
2.4 times 2.4 times 2.4. Wait, is length times width times height?
Yeah.
What about 2?
And what does that give you?
The volume.
The volume.
What?
2.4 times 2.4 times 2.4.
No, 2.4 times 2. No, 2.4 times 2.
10 point.
10.23.
No points.
Did you do the oil already?
Yes.
What was your prediction? Which was going to be more?
Water is denser. Is denser than oil, but I wrote oil
And how do you know?
because oil floats on water.
Because oil what?
I've seen oil float on water.
Oh, okay. So you have experience, personal background knowledge. But how can you prove it in a laboratory?
You measured the density
And in
because it's mass divided by volume, and
Well, the density of water is
18.5 divided by 14.5. Oh, I don't have 2.5. Even though it's a longer number.
so how do you calculate the volume now?
I'm supposed to do length times width times height.
Okay.
So length.
Alright, great job. I like what I see. Keep an eye on the time. How about a minute? Boys, think about this. Now you're getting the mass, right? The volume is the same for all these cubes. So the important thing is get the mass for the time goes off.
That doesn't make any sense.
You have one more cube. You can do that. I got confidence.